What if everything we think we know about the universe is only a fraction of the truth? Picture this: the stars, the galaxies, the planets, everything we see, touch, and study makes up just 15% of the cosmos. The rest, it's gone, vanished, or so it seems. Scientists call it dark matter, an invisible force that holds the universe together, yet no one can see it, touch it, or even prove it exists. But what if it's not just a scientific mystery? What if dark matter's disappearance is no accident? What if someone, or something, is hiding it from us? From secret government experiments to advanced alien technologies, the theories are as vast as the cosmos itself. Could dark matter be the key to unlocking the universe's greatest secrets? Or is it a cosmic cover-up designed to keep us in the dark? Stay with us, because by the end of this video, you'll uncover the chilling possibilities behind the missing 85% of the universe, and why some believe the truth is being deliberately concealed. The universe is full of mysteries, but this one might just change everything you thought you knew. Let's dive in. Now, let's take a closer look at what dark matter actually is. Imagine you're at a concert and you can hear the music, feel the bass vibrating through your chest, and see the crowd swaying to the rhythm. But here's the twist: you can't see the speakers. That's dark matter. It's the invisible force that shapes the universe, influencing everything around it, yet it remains completely hidden from our eyes. Dark matter was first discovered in the 1930s by a Swiss astronomer named Fritz Zwicky. He noticed something strange while studying galaxy clusters. The galaxies were moving so fast that, according to the laws of physics, they should have flown apart, but they didn't. Something unseen was holding them together. Zwicky called this mysterious force dark matter, and the name stuck. Decades later, in the 1970s, astronomer Vera Rubin provided even more evidence. She observed that stars at the edges of galaxies were moving just as fast as those near the center, defying expectations. The only explanation, an invisible mass, dark matter, was exerting a gravitational pull. So, why do scientists believe dark matter makes up 85% of the universe's mass? Think of it like this: if the universe were a giant iceberg, the stars, planets, and galaxies we see would be just the tip. The rest, the vast, hidden bulk beneath the surface, is dark matter. It doesn't emit, absorb, or reflect light, making it impossible to detect with traditional telescopes. But its presence is undeniable. Without dark matter, galaxies wouldn't hold together, and the universe as we know it wouldn't exist. To put it simply, dark matter is the cosmic glue that keeps everything in place. It's the reason galaxies spin the way they do, why clusters of galaxies stay bound together, and why the universe looks the way it does. And while we can't see it, we know it's there because of its gravitational effects. It's like feeling the wind on your face. You can't see the air, but you know it's there because of how it moves things around you. So, what's next in this cosmic mystery? Let's explore how scientists are trying to uncover the secrets of dark matter and why it's proving to be one of the most elusive puzzles in the universe. Now, let's dig deeper into the mystery of the missing 85%. Why is such a massive portion of the universe's mass unaccounted for? To understand this, we need to look at the clues left behind by dark matter, clues that scientists have been piecing together for decades. One of the most compelling pieces of evidence comes from gravitational effects. Imagine throwing a ball into the air. You expect it to come back down because of Earth's gravity. Now picture a galaxy. The stars within it should behave similarly, orbiting the center due to gravity. But here's the catch. When astronomers measure the speed of stars in galaxies, especially those at the outer edges. They're moving far faster than they should be. According to the visible matter, stars, gas, and dust, there's simply not enough gravity to keep them in place. So, what's holding these galaxies together? The answer lies in the invisible gravitational pull of dark matter, acting like an unseen hand, keeping everything from flying apart. Next, let's talk about galaxy rotation curves. These are graphs that plot the speed of stars against their distance from the center of a galaxy. If only visible matter existed, we'd expect stars on the outskirts to move slower, just like planets farther from the sun orbit more slowly. But that's not what we see. Instead, stars at the edges of galaxies move just as fast as those near the center. This flat rotation curve is a telltale sign of dark matter's presence, suggesting that there's a massive, invisible halo surrounding galaxies, exerting its gravitational influence. Then there's the cosmic microwave background radiation, often called the afterglow of the Big Bang. This faint radiation fills the entire universe and provides a snapshot of the early cosmos. When scientists analyze it, they find tiny fluctuations in temperature that reveal how matter was distributed shortly after the universe began. These fluctuations match predictions that include dark matter. Without it, the universe's structure, galaxies, clusters, and the vast cosmic web wouldn't have formed the way it did. Dark matter's gravitational pull acted as the scaffolding, guiding the growth of everything we see today. So, why does all this matter? Because it tells us that dark matter isn't just a theoretical idea, it's a real, tangible force shaping the universe. And yet, despite all the evidence, we still can't see it, touch it, or fully understand it. This missing 85% isn't just a gap in our knowledge, it's a cosmic puzzle waiting to be solved. What could dark matter be made of? How does it interact with the rest of the universe? And why has it remained so elusive? These are the questions driving scientists to push the boundaries of what we know. As we continue to explore, one thing is clear: dark matter is the key to unlocking some of the universe's deepest secrets. And while we may not have all the answers yet, every discovery brings us one step closer to understanding the invisible force that holds everything together. Now, let's take a step back in time to uncover the origins of dark matter theories. The story begins in the 1930s with a Swiss astronomer named Fritz Zwicky. While studying the Coma Cluster, a massive group of galaxies, Zwicky noticed something peculiar. The galaxies within the cluster were moving at speeds that defied explanation. Based on the visible matter he could observe, there simply wasn't enough mass to account for the gravitational forces holding the cluster together. Zwicky coined the term dark matter to describe this invisible, mysterious substance that must be exerting a gravitational pull. His groundbreaking observation was the first hint that the universe might be hiding far more than meets the eye. Fast forward to the 1970s, and another astronomer, Vera Rubin, would take Zwicky's work to the next level. Rubin was studying the rotation of galaxies, focusing on how stars moved within them. She discovered that stars at the edges of galaxies were orbiting just as fast as those near the center, a phenomenon that shouldn't be possible if only visible matter existed. This flat rotation curve, as it's called, was a direct challenge to our understanding of gravity and mass. Rubin's findings provided some of the strongest evidence yet for the existence of dark matter, solidifying its place as a cornerstone of modern cosmology. These early discoveries didn't just introduce the concept of dark matter, they fundamentally changed how we view the universe. Zwicky and Rubin's work laid the groundwork for a new understanding of cosmic structure, showing that the visible universe is just the tip of the iceberg. their insights sparked a wave of research, leading to the development of new tools and technologies designed to probe the invisible universe. From gravitational lensing to particle detectors, the quest to uncover dark matter's secrets has become one of the most exciting and challenging endeavors in modern science. What's fascinating is how these early theories have stood the test of time. Despite decades of research, dark matter remains as elusive as ever, yet its influence is undeniable. Zwicky and Rubin's pioneering work reminds us that sometimes the most profound discoveries come from questioning what we think we know. As we continue to explore the cosmos, their legacy serves as a reminder that the universe is full of mysteries waiting to be uncovered, and that the answers might be hiding in the shadows, just out of sight. Now, let's shift our focus to the cutting-edge efforts of modern science in the hunt for dark matter. Today, researchers are using some of the most advanced tools ever created to try and catch a glimpse of this elusive substance. One of the most famous is the Large Hadron Collider, the world's most powerful particle accelerator. Located deep underground near Geneva, this colossal machine smashes particles together at nearly the speed of light, hoping to create conditions where dark matter might reveal itself. While the collider has made groundbreaking discoveries, like the Higgs boson, dark matter remains frustratingly out of reach. Scientists believe that if dark matter is made of particles, the collider might one day produce them, but so far, no luck. Another approach involves underground detectors, like those buried deep in abandoned mines or beneath mountains. These facilities are designed to shield experiments from cosmic rays and other interference, creating a quiet environment where even the faintest signals from dark matter could be detected. One such experiment, known as the Large Underground Xenon Detector, uses liquid xenon to try and capture interactions with dark matter particles. Despite years of operation, these detectors have yet to provide a definitive signal, leaving scientists to wonder if they're looking in the right place, or if dark matter is even more elusive than we thought. Space-based observatories are also playing a crucial role in the search. Telescopes like the Hubble Space Telescope and the upcoming James Webb Space Telescope are mapping the universe in unprecedented detail, looking for clues in the way light bends around massive objects, a phenomenon known as gravitational lensing. These observations help scientists map the distribution of dark matter in the cosmos, even if they can't see it directly. Meanwhile, missions like the European Space Agency's Euclid satellite aim to study the large-scale structure of the universe, hoping to uncover more about dark matter's role in shaping galaxies and galaxy clusters. So why, after decades of research and billions of dollars invested, have we still not found dark matter? One possibility is that dark matter doesn't interact with ordinary matter in the way we expect. It might be completely invisible to our current detectors, requiring entirely new methods to uncover. Another theory suggests that dark matter could be far more complex than we've imagined, perhaps made up of multiple types of particles or behaving in ways that defy our current understanding of physics. Whatever the case, the search continues, driven by the tantalizing possibility that solving this mystery could revolutionize our understanding of the universe. As we push the boundaries of technology and knowledge, one thing is clear: the quest for dark matter is far from over. Each experiment, each observation, brings us closer to uncovering the truth, or perhaps to realizing that the universe is even stranger than we ever imagined. And with every step forward, we're reminded that the greatest discoveries often lie just beyond the edge of what we can see. But what if the reason we haven't found dark matter yet isn't just because it's hard to detect? What if its elusive nature is intentional? This is where the conspiracy theories begin to take shape. Imagine for a moment, that dark matter isn't just a cosmic mystery, it's a secret being kept from us. Who could be hiding it, and why? The idea might sound like science fiction, but it's a question that has sparked intense speculation among both scientists and conspiracy theorists alike. Some suggest that governments around the world might be concealing the truth about dark matter. After all, if dark matter holds the key to unimaginable energy sources or advanced technologies, controlling that knowledge could give a nation unprecedented power. Think about it. During the Cold War, scientific breakthroughs were often classified for military advantage. Could dark matter be the next big secret, hidden away in classified labs or black-budget projects? The possibility is tantalizing and unsettling. Others take the conspiracy even further, proposing that dark matter might not just be hidden by humans. What if an advanced extraterrestrial civilization is manipulating it for their own purposes? Could dark matter be the foundation of alien technology, allowing them to travel vast distances or even cloak their presence from us? This theory ties into the Fermi paradox, which asks why, in a universe so vast, we haven't found evidence of other intelligent life. Maybe the answer lies in dark matter, a tool so advanced it's invisible to our current understanding. Of course, not everyone buys into these ideas. Many scientists argue that dark matter's elusiveness is simply a reflection of how little we know about the universe. They point out that throughout history, what we once thought were mysteries or conspiracies often turned out to be gaps in our knowledge. But even among skeptics, the question lingers: what if there's more to the story? What if dark matter's invisibility isn't just a quirk of nature, but a deliberate act? As we explore these theories, it's important to remember that the truth is still out there, waiting to be discovered. Whether dark matter is hidden by human hands, alien minds, or simply the laws of physics, one thing is certain: the search for answers is far from over. And as we dig deeper, we might find that the universe is hiding more secrets than we ever imagined. So, who do you think could be hiding dark matter, and why? The possibilities are as vast as the cosmos itself. Now, let's take a closer look at who might be behind the curtain, pulling the strings to keep dark matter hidden from the rest of us. Governments are often the first suspects when it comes to conspiracy theories, and for good reason. Throughout history, nations have kept scientific discoveries under wraps for strategic advantages. If dark matter holds the potential for revolutionary energy sources or advanced technologies, it's not hard to imagine why a government might want to control that knowledge. Picture this: a breakthrough in dark matter research could lead to energy systems that dwarf nuclear power, or propulsion technologies that make space travel as routine as air travel. The nation that unlocks these secrets could dominate the global stage, both economically and militarily. It's a high-stakes game, and the temptation to keep such discoveries classified would be immense. But governments aren't the only players in this cosmic mystery. Secret organizations, operating outside the bounds of public oversight, could also be in the mix. These groups, often shrouded in mystery themselves, might have the resources and influence to conduct dark matter research in the shadows. Think of organizations like those rumored to be involved in classified aerospace projects or cutting-edge scientific experiments. If dark matter is as powerful as some theories suggest, these groups could see it as the ultimate prize, a tool to reshape the world according to their vision. The motivations here could range from profit to power, or even a desire to control the future of humanity itself. Then there's the most intriguing possibility of all. extraterrestrial involvement. What if dark matter isn't just a natural phenomenon, but a technology wielded by advanced alien civilizations? Imagine a species so far ahead of us that they've mastered the manipulation of dark matter, using it to travel between stars or cloak their presence from detection. If such beings exist, they might have a vested interest in keeping dark matter a secret from us. After all, if humanity were to unlock the secrets of dark matter, we could become a threat, or perhaps even a rival. This idea ties back to the Fermi paradox, which questions why we haven't encountered other intelligent life despite the vastness of the universe. Could dark matter be the key to answering that question? It's a thought that blurs the line between science and science fiction, but in the realm of conspiracy theories, the line is often thin. Of course, not everyone believes these theories. Many scientists argue that dark matter's elusiveness is simply a reflection of our limited understanding of the universe. They point out that throughout history, what we once thought were conspiracies often turned out to be gaps in our knowledge. But even among skeptics, the question remains, what if there's more to the story? What if dark matter's invisibility isn't just a quirk of nature, but a deliberate act? As we continue to explore these possibilities, one thing is clear: the mystery of dark matter is as much about who might be hiding it as it is about what it actually is. And as we dig deeper, we might find that the truth is stranger and more fascinating than we ever imagined. Now, let's turn our gaze beyond Earth and consider a possibility that stretches the boundaries of imagination: extraterrestrial involvement in the dark matter mystery. Could advanced alien civilizations be manipulating dark matter for their own purposes? This idea might sound like the plot of a science fiction movie, but when we examine the evidence, or lack thereof, it's a theory that raises fascinating questions. The Fermi paradox, which asks why we haven't encountered other intelligent life despite the vastness of the universe, becomes even more intriguing when we consider dark matter. If alien civilizations exist, they might have technologies far beyond our comprehension, including the ability to harness or control dark matter. Imagine a species that has mastered the manipulation of this invisible substance, using it to power their civilizations, travel between stars, or even cloak their presence from detection. Dark matter, with its mysterious properties, could be the cornerstone of their technological advancements, something so advanced that it remains entirely hidden from us. But why would they hide it? One possibility is that dark matter is a resource too powerful to share. If these civilizations have unlocked its potential, they might see humanity as a potential threat or rival. By keeping dark matter a secret, they could maintain their dominance and prevent us from catching up. Another theory suggests that dark matter could be used as a form of cosmic camouflage, allowing alien civilizations to remain undetected while observing or even influencing our development. This would explain why we haven't found concrete evidence of extraterrestrial life. They might be hiding in plain sight, using dark matter as their shield. Of course, these ideas are speculative, but they highlight the profound implications of dark matter's role in the universe. If dark matter is not just a natural phenomenon, but a tool wielded by advanced beings, it could reshape our understanding of everything from physics to the search for extraterrestrial intelligence. The Fermi paradox, often seen as a question about the absence of alien life, might instead be a question about the limits of our perception. Could dark matter be the key to unlocking the mystery of why we seem so alone in the cosmos? As we ponder these possibilities, one thing becomes clear: the mystery of dark matter is not just about what it is, but who might be using it. whether or not extraterrestrial civilizations are involved, the idea challenges us to think beyond the boundaries of our current knowledge and consider the universe as a place filled with secrets waiting to be uncovered. And as we continue to explore, we might find that the truth is far more extraordinary than we ever imagined. Now, shifting our focus closer to home, let's explore another layer of the dark matter conspiracy, the possibility of government cover-ups. Could powerful nations be hiding research on dark matter to gain military or economic advantages? While this might sound like the stuff of spy novels, history is filled with examples of governments keeping groundbreaking scientific discoveries under wraps for strategic purposes. Take, for instance, the Manhattan Project during World War II. This top-secret initiative to develop the atomic bomb was hidden from the public and even most government officials until its devastating results were revealed. The project's success not only changed the course of the war, but also reshaped global power dynamics. If governments were willing to conceal something as world-altering as nuclear technology, could they be doing the same with dark matter? Dark matter's potential applications are staggering. If harnessed, it could revolutionize energy production, space travel, and even weaponry. Imagine a nation developing a dark matter-powered energy grid, rendering fossil fuels obsolete and securing unparalleled economic dominance. Or consider the military implications. Dark matter could theoretically be used to create stealth technology far beyond anything we've seen, making entire fleets or bases invisible to detection. The stakes are astronomically high, and the temptation to keep such discoveries secret would be immense. Historical precedents also suggest that governments often prioritize secrecy over transparency when it comes to scientific breakthroughs. During the Cold War, both the United States and the Soviet Union invested heavily in classified research programs, from advanced aerospace technology to mind control experiments. Many of these projects remained hidden for decades, only coming to light through declassified documents or whistleblowers. If dark matter research holds similar potential, it's not far-fetched to think it could be locked away in secret labs, accessible only to a select few. But why would governments hide such knowledge? Beyond military and economic advantages, there's also the question of control. Dark matter could fundamentally alter our understanding of the universe, potentially leading to technologies that disrupt the existing global order. By keeping this research classified, governments could maintain their grip on power, ensuring that no rival nation or group gains access to these transformative capabilities. Of course, this theory raises ethical questions. Should scientific discoveries that could benefit humanity be kept hidden for the sake of national security? And if dark matter is being concealed, how long can it remain a secret in an age of increasing transparency and technological advancement? As we consider these possibilities, it's worth remembering that the truth often lies somewhere between conspiracy and reality. Whether or not governments are hiding dark matter research, the idea challenges us to think critically about the balance between progress and power. And as we continue to explore the mysteries of the universe, we might find that the greatest secrets are not in the stars, but closer to home than we ever imagine. Now, turning our attention to the scientific community, let's explore why many experts remain skeptical about the idea of a dark matter conspiracy. While the notion of hidden knowledge and secret agendas makes for compelling storytelling, the majority of scientists approach dark matter as a natural, albeit mysterious, part of the universe. Their skepticism isn't rooted in dismissing the unknown, but in relying on evidence, rigorous testing, and the scientific method to uncover the truth. One of the key reasons scientists are hesitant to embrace conspiracy theories is the overwhelming observational evidence supporting dark matter's existence. From the way galaxies rotate to the bending of light in gravitational lensing, the effects of dark matter are visible across the cosmos. These phenomena aren't easily explained by known physics, and dark matter provides a consistent framework to account for them. For most researchers, the idea that these observations are the result of a deliberate cover-up doesn't hold up under scrutiny. Instead, they see dark matter as a puzzle to be solved, not a secret to be uncovered. Another factor driving skepticism is the collaborative nature of modern science. Unlike classified military projects, dark matter research is conducted by thousands of scientists worldwide, working in universities, research institutions, and international collaborations like the Large Hadron Collider. With so many eyes on the data, the likelihood of a global conspiracy to hide dark matter seems implausible. Scientific discoveries thrive on transparency and peer review, making it difficult to conceal something as fundamental as dark matter without someone raising the alarm. Moreover, the scientific community often favors the simplest explanation that fits the evidence, a principle known as Occam's razor, while conspiracy theories introduce layers of complexity, such as secret organizations or hidden agendas. The natural explanation that dark matter is an undiscovered particle or force requires fewer assumptions. This doesn't mean scientists aren't open to unconventional ideas, but they prioritize explanations that align with existing knowledge and can be tested through experimentation. It's also worth noting that skepticism about dark matter conspiracies doesn't mean scientists dismiss the possibility of unknown forces or phenomena. In fact, many are actively exploring alternative theories, such as modified Newtonian dynamics or MOND, which suggests that our understanding of gravity might need revision. However, these alternatives are rigorously tested against the evidence, and so far, dark matter remains the most widely accepted explanation. Ultimately, the scientific approach to dark matter is one of curiosity and exploration, not secrecy. While conspiracy theories capture our imagination, they often overlook the meticulous work being done to understand the universe. For scientists, the mystery of dark matter isn't about who might be hiding it. It's about unraveling one of the greatest puzzles in modern physics. And as we continue to probe the cosmos, the answers we seek may be closer than we think. Now, let's shift our focus to some of the alternative explanations that challenge the dark matter narrative. While dark matter remains the leading theory to explain the universe's missing mass, there are other intriguing ideas that propose different solutions to the mystery. One of the most prominent alternatives is modified Newtonian dynamics, or MOND. This theory suggests that our understanding of gravity might be incomplete, and that the laws governing it could behave differently on cosmic scales than they do here on Earth. Instead of invoking an invisible substance like dark matter, MOND proposes that gravity itself might need a tweak to account for the observed phenomena, such as the way galaxies rotate faster than expected. MOND has its supporters, and it does a surprisingly good job at explaining certain observations, particularly the rotation curves of galaxies. However, it struggles to account for other cosmic phenomena, such as the gravitational lensing effects seen in galaxy clusters or the large-scale structure of the universe. These limitations have kept MOND from gaining widespread acceptance, but it remains a fascinating alternative that pushes scientists to question their assumptions about gravity and the cosmos. Another set of theories explores the idea of modifying Einstein's theory of general relativity. these approaches suggest that gravity might operate differently on extremely large scales, potentially eliminating the need for dark matter altogether. While these ideas are mathematically elegant, they often require introducing new, untested components or forces, which can make them less appealing than the simpler dark matter hypothesis. Still, they highlight the creativity and ingenuity of scientists as they grapple with one of the universe's biggest mysteries. It's also worth mentioning that some researchers have proposed that dark matter might not be a single type of particle, but a combination of different particles or even exotic objects like primordial black holes. These ideas add layers of complexity to the dark matter puzzle, but also open up new avenues for exploration. While they don't replace the need for dark matter, they expand the possibilities of what it could be. Despite the appeal of these alternatives, dark matter remains the most widely accepted explanation because it consistently explains a broad range of observations across the universe. The alternatives, while intriguing, often require more assumptions or fail to account for all the evidence. This doesn't mean their wrong. Science thrives on questioning established ideas, but it does mean they have more to prove before they can challenge the dark matter paradigm. What's fascinating about these alternative theories is that they remind us how much we still have to learn about the universe. Whether it's tweaking gravity, rethinking general relativity, or exploring exotic particles, these ideas push the boundaries of our understanding and keep the scientific conversation alive. And as we continue to probe the cosmos, who knows, one of these alternatives might just hold the key to unlocking the mystery of the universe's missing mass. Now, let's take a step into the realm of the multiverse, where the mysteries of dark matter might stretch far beyond our own universe. One of the most mind-bending ideas in modern physics is the concept of the multiverse, the idea that our universe is just one of countless others, each with its own unique set of physical laws and properties. But what if dark matter isn't just a feature of our universe? What if it's a cosmic thread connecting us to these parallel dimensions? Some scientists have proposed that dark matter could be a kind of bridge between our universe and others. Imagine dark matter as a hidden network, a kind of cosmic scaffolding that not only holds our universe together, but also links it to other realms we can't yet see. This idea suggests that dark matter particles might interact with forces or dimensions beyond our own, creating a kind of overlap between universes. It's a wild thought, but it could explain why dark matter is so elusive. It might not fully belong to our universe in the first place. This connection to the multiverse could also shed light on why dark matter behaves the way it does. For instance, its gravitational effects are felt strongly in our universe, but it doesn't interact with light or ordinary matter in the ways we'd expect. If dark matter is influenced by forces from other dimensions, it might operate under rules we don't yet understand. This could mean that what we perceive as dark matter is just the tip of the iceberg, a glimpse into a much larger and more complex cosmic structure. The multiverse theory also raises fascinating questions about the nature of reality itself. If dark matter is a bridge to other dimensions, could it be a pathway for communication or even travel between universes? While this sounds like science fiction, it's a possibility that some physicists take seriously. Experiments like those at the Large Hadron Collider are already searching for evidence of extra dimensions, and dark matter could be the key to unlocking this deeper layer of reality. Of course, this is all speculative, and the multiverse remains a highly debated topic in the scientific community. But the idea that dark matter might be intertwined with parallel dimensions adds an exciting layer to the mystery. It challenges us to think bigger, to consider that the universe's missing mass might not just be hidden, it might be part of something far grander than we've ever imagined. As we continue to explore the cosmos, the connection between dark matter and the multiverse offers a tantalizing possibility that the answers to our universe's greatest mysteries might lie in realms we've yet to discover. And who knows, one day we might find that dark matter isn't just a puzzle to solve, it's a doorway to understanding the true nature of existence itself. Now, shifting our focus slightly, let's untangle the often confused concepts of dark matter and dark energy. While both are fundamental to understanding the universe, they play very different roles in shaping its structure and destiny. Dark matter, as we've explored, is the invisible force that holds galaxies together, acting like cosmic glue through its gravitational pull. But dark energy, that's a whole different story. Dark energy is the mysterious force driving the accelerated expansion of the universe. Unlike dark matter, which pulls things together, dark energy pushes them apart. Imagine the universe as a balloon being inflated. Dark energy is the breath that keeps blowing into it, causing space itself to stretch faster and faster over time. This expansion isn't just happening on a large scale, it's happening everywhere, even in the seemingly empty voids between galaxies. So, why is dark matter the star of the conspiracy theories, while dark energy often takes a backseat? The answer lies in their effects on the universe. Dark matter's gravitational influence is something we can observe indirectly, through the way galaxies rotate, how light bends around massive objects, and the large-scale structure of the cosmos. These observable effects make dark matter feel tangible, even if we can't see it directly. Dark energy, on the other hand, is far more abstract. Its effects are subtle and spread out over vast distances, making it harder to pin down or imagine as something that could be hidden or manipulated. Another key difference is how they interact with the universe's timeline. Dark matter has been shaping the cosmos since its early days, helping galaxies and clusters form over billions of years. Dark energy, however, became dominant much later, only taking the reins in the last few billion years as the universe expanded and matter spread out. This delayed influence makes dark energy feel more like a background player, even though it's now the dominant force in the universe. But here's where things get interesting. While dark matter is the focus of conspiracy theories because of its tangible effects and mysterious nature, dark energy's role in the universe's expansion raises its own set of questions. Could dark energy be hiding something too? Some theorists speculate that its accelerating effect on the universe might be a sign of something deeper, perhaps even a clue to the ultimate fate of the cosmos. Will the universe keep expanding forever, or will dark energy's push eventually lead to a dramatic cosmic event, like the Big Rip? For now, dark matter remains the center of attention in the conspiracy realm because its effects are easier to imagine as being manipulated or concealed. But as we continue to explore the universe, the interplay between dark matter and dark energy reminds us that there's still so much we don't understand. Both forces are essential pieces of the cosmic puzzle, and unraveling their mysteries could bring us closer to understanding the true nature of reality. Now, let's turn our attention to some of the most fascinating cosmic anomalies that have left scientists scratching their heads and conspiracy theorists buzzing with ideas. One of the most compelling pieces of evidence for dark matter comes from observations of the Bullet Cluster, a pair of galaxy clusters that collided millions of years ago. What makes this collision so extraordinary is that it provides a rare glimpse into the behavior of dark matter, When these clusters smashed together, their visible matter, like gas and stars, interacted and slowed down, but the dark matter kept moving, seemingly unaffected. This separation between visible matter and dark matter was captured in stunning detail, offering a visual, smoking gun for dark matter's existence. Yet, for some, this very evidence raises more questions than answers. If dark matter is so elusive, how can we be sure it's not being manipulated or hidden by some unknown force? Another anomaly that supports the dark matter hypothesis is the way galaxies form and behave. Without dark matter, galaxies wouldn't have enough gravitational pull to hold themselves together. The outer stars in galaxies rotate at speeds that defy the laws of physics as we understand them, unless there's an invisible mass providing the extra gravity needed. This discrepancy, known as the galaxy rotation problem, has been a cornerstone of dark matter research. But here's where conspiracy theories creep in. If dark matter is so crucial to the structure of the universe, why can't we detect it directly? Could it be that someone, or something, is preventing us from uncovering the truth? These cosmic anomalies don't just challenge our understanding of the universe, they also ignite the imagination. The bullet cluster, for instance, has been cited by some as evidence of advanced alien technology or even a cosmic cover-up. Could dark matter be a tool used by extraterrestrial civilizations to manipulate the fabric of space? Or is it possible that governments are hiding the true nature of dark matter to maintain control over scientific knowledge? While these ideas may sound far-fetched, they thrive in the gaps of our understanding, filling the void with speculation and intrigue. What's undeniable is that these anomalies highlight the limits of our current knowledge. They remind us that the universe is far stranger and more complex than we can imagine. And as long as dark matter remains a mystery, it will continue to fuel both scientific curiosity and wild conspiracy theories. So, the next time you look up at the night sky, remember, the cosmos is full of secrets, and some of them might be hiding in plain sight. Now, let's shift our focus to the cutting-edge tools that might finally crack the mystery of dark matter. As our understanding of the universe deepens, so does our reliance on technology to push the boundaries of what we can observe and measure. One of the most promising areas is artificial intelligence, or AI. With its ability to process vast amounts of data at incredible speeds, AI is revolutionizing how scientists analyze cosmic phenomena. For instance, AI algorithms can sift through the noise of telescope observations to identify subtle patterns that might hint at dark matter's presence. These patterns, invisible to the human eye, could hold the key to detecting dark matter particles or understanding their behavior. Another game changer is quantum computing. Unlike traditional computers, which rely on binary code, quantum computers operate using qubits, allowing them to perform complex calculations at unprecedented speeds. This could be a game changer for dark matter research. Quantum simulations might help us model the behavior of dark matter in ways that were previously impossible, offering new insights into its properties and interactions. Imagine being able to recreate the conditions of the early universe in a lab, or simulate how dark matter influences galaxy formation. These breakthroughs could bring us closer than ever to solving the puzzle. But it's not just about processing power. Advances in detector technology are also playing a crucial role. Experiments like the Large Hadron Collider and underground dark matter detectors are becoming more sensitive, capable of picking up even the faintest signals that might indicate dark matter's presence. These detectors are now being paired with AI to enhance their accuracy, creating a powerful synergy between hardware and software. Together, they're opening up new possibilities for discovery. Of course, technology alone isn't the answer. It's the combination of human ingenuity and technological innovation that drives progress. As we develop more sophisticated tools, we're also refining our theories and asking better questions. This iterative process is what makes science so exciting and so unpredictable. Who knows what breakthroughs might be just around the corner? Perhaps the next big discovery will come from a combination of AI, quantum computing, and a stroke of scientific intuition. As we look to the future, one thing is clear: technology is our best hope for unraveling the secrets of dark matter. Whether it's through AI, quantum simulations, or next-generation detectors, these tools are giving us a fighting chance to uncover the truth. And when that day comes, it won't just be a victory for science, it will be a triumph for humanity's relentless curiosity and determination to understand the cosmos. So, as we continue to push the limits of what's possible, let's keep our eyes on the stars and the invisible forces that shape them. Now, let's step into the world of storytelling and see how dark matter has captured the imagination of creators and audiences alike. Dark matter, with its mysterious and elusive nature, has become a favorite theme in movies, TV shows, and books. These portrayals often take creative liberties, blending science with fiction to craft compelling narratives. But how do these depictions shape the way we think about dark matter, and could they be fueling some of the conspiracy theories we've explored? Take, for example, blockbuster films like Interstellar or The Dark Knight Rises. In these stories, dark matter is often portrayed as a powerful, almost magical force that can bend the rules of physics. While these interpretations are thrilling, they sometimes blur the line between fact and fiction, leaving audiences with a skewed understanding of what dark matter actually is. This mix of science and fantasy can make the concept seem more mysterious or even sinister than it really is. Television series have also embraced dark matter as a central theme. Shows like The X-Files and Stranger Things often use it as a plot device to explain unexplained phenomena or to introduce otherworldly elements. These portrayals can amplify the sense of mystery surrounding dark matter, making it seem like something that's not just unknown, but potentially dangerous or even supernatural. For viewers who aren't familiar with the scientific background, these depictions can easily feed into conspiracy theories, suggesting that dark matter might be hiding something far more extraordinary than we realize. Books, too, have played a significant role in shaping public perception. Science fiction novels often explore dark matter as a gateway to parallel universes or advanced alien civilizations. Authors like Philip Pullman, in his Dark Materials series, use dark matter as a metaphor for deeper philosophical and spiritual questions. While these stories are fascinating, they can also contribute to the idea that dark matter is more than just a scientific puzzle. It's a cosmic enigma with profound implications for humanity. But here's the interesting part. These creative portrayals, while not always scientifically accurate, have a unique power to spark curiosity. They draw people into the mystery of dark matter, encouraging them to ask questions and seek out real-world explanations. For some, this might lead to a deeper interest in science. For others, it might fuel the belief that there's more to dark matter than meets the eye, perhaps even a hidden truth being kept from the public. So, while popular culture may not always get the science right, it undeniably plays a role in how we perceive dark matter. These stories remind us that the universe is full of wonders we've yet to understand, and they keep the conversation alive. Whether they inspire awe, fear, or curiosity, they've made dark matter a topic that resonates far beyond the confines of scientific research. And as we continue to explore the mysteries of the cosmos, it's worth considering how these cultural narratives shape our quest for knowledge and our willingness to believe in the unknown. Now, let's take a step back and look at history. Throughout the years, there have been moments when scientific discoveries were shrouded in secrecy, sparking whispers of conspiracy. These historical precedents might help us understand why some people are quick to believe that dark matter could be part of a larger, hidden truth. After all, if science has been kept under wraps before, why not now? Take the Manhattan Project, for instance. During World War II, the United States secretly developed the atomic bomb, bringing together some of the brightest minds in physics. The project was so classified that even many of the scientists involved didn't fully understand the scope of what they were working on. It wasn't until the bombs were dropped on Hiroshima and Nagasaki that the world learned the truth. This massive, top-secret effort showed how scientific breakthroughs could be hidden from the public, and even from most of the scientific community, for years. Then there's the Cold War era, a time when espionage and secrecy were at their peak. Both the United States and the Soviet Union raced to develop advanced technologies, from nuclear weapons to space exploration. Projects like the U-2 spy plane and the development of stealth technology were kept under tight wraps, with governments going to great lengths to protect their secrets. These examples remind us that when national security or strategic advantage is at stake, scientific discoveries can become tightly guarded secrets, but it's not just about weapons or warfare. Even in peacetime, there have been instances where scientific research was kept hidden. For example, in the 1970s, the tobacco industry funded studies to downplay the health risks of smoking. These studies were deliberately kept from the public, creating a false narrative that lasted for decades. It wasn't until whistleblowers and lawsuits brought the truth to light that people realized how much had been concealed. So, what does this mean for dark matter? Well, these historical examples show that it's not entirely far-fetched to think that scientific discoveries could be hidden from the public. If governments and organizations have done it before, could they be doing it again? Some conspiracy theorists argue that dark matter's elusive nature might not just be a scientific challenge. It could be a deliberate effort to keep us in the dark. Of course, it's important to remember that most scientists believe dark matter is simply a natural phenomenon we haven't fully understood yet. But the history of scientific secrecy does raise an intriguing question. If dark matter holds the key to revolutionary technologies or cosmic truths, would those in power want to keep it hidden? As we continue to explore the mysteries of the universe, these historical precedents remind us that the line between science and secrecy can sometimes be thinner than we think. Now, let's shift our focus to a question that sits at the heart of this mystery. Is it ever ethical to keep scientific discoveries hidden from the public? When it comes to something as profound as dark matter, the stakes are undeniably high. Could there ever be a justification for withholding such knowledge, or does transparency always take precedence? On one hand, there's a strong argument for openness. Science thrives on collaboration and the free exchange of ideas. When discoveries are shared, they can spark new breakthroughs, inspire future generations, and help humanity collectively solve some of its greatest challenges. Imagine if the principles of electricity or the structure of DNA had been kept secret, our world would look very different today. By sharing knowledge, we empower everyone to benefit from progress, not just a select few. But what if the discovery in question has the potential to be dangerous? This is where the ethical debate becomes more complex. Take, for example, the development of nuclear technology. While it has brought us clean energy and medical advancements, it also introduced the threat of catastrophic weapons. If dark matter were to unlock similarly powerful technologies, could there be a case for keeping it under wraps to prevent misuse? Some might argue that in a world where power imbalances and conflicts exist, certain knowledge could be too risky to release without safeguards. Then there's the question of who gets to decide what's shared and what's kept secret. Governments, corporations, and even scientific institutions all have their own agendas. If dark matter were to be discovered, would these entities act in the best interest of humanity, or would they prioritize their own power and profit? History has shown us that when information is controlled by a select few, it often leads to inequality and exploitation. The ethical dilemma here is whether the potential benefits of secrecy outweigh the risks of creating a knowledge gap that could deepen societal divides. At the same time, some might argue that not all information needs to be public immediately. Scientific discoveries often require time to be fully understood and responsibly applied. Releasing incomplete or misunderstood findings could lead to panic, misinformation, or even harmful actions. For instance, if dark matter were revealed to have properties that challenge our understanding of reality, how would society react? Could the truth be too destabilizing to handle all at once? Ultimately, the ethics of secrecy in science come down to a balancing act. On one side, there's the moral imperative to share knowledge for the greater good. On the other, there's the responsibility to protect humanity from potential harm. When it comes to dark matter, the question isn't just about what we know, it's about what we're ready to handle. As we continue to explore the cosmos, these ethical considerations remind us that the pursuit of knowledge is as much about wisdom as it is about discovery. Now, let's turn our attention to how the general public perceives dark matter, a topic that often feels as mysterious as the phenomenon itself. For many, dark matter is a concept that exists somewhere between science fiction and reality. It's not something we can see or touch, and yet, it's said to make up the majority of the universe. This disconnect between what we know and what we experience has led to a wide range of interpretations, some of which are rooted in science, while others drift into the realm of speculation and conspiracy. One of the most common misconceptions about dark matter is that it's inherently dangerous or malevolent. Thanks to its name and the way it's often portrayed in popular media, many people imagine it as a shadowy force lurking in the cosmos, waiting to wreak havoc. Movies and TV shows have only amplified this idea, often depicting dark matter as a mysterious substance capable of causing black holes, time distortions, or even alien invasions. While these portrayals make for thrilling entertainment, they also contribute to a skewed understanding of what dark matter actually is, a neutral, invisible component of the universe that plays a crucial role in holding galaxies together. Another widespread belief is that dark matter is a solved mystery, or at least one that scientists are close to cracking. In reality, despite decades of research, dark matter remains one of the greatest unsolved puzzles in physics. This gap between public perception and scientific reality can lead to frustration or skepticism. Some people wonder why, with all our advanced technology, we still haven't found definitive answers. This uncertainty has created fertile ground for conspiracy theories, with some suggesting that dark matter's elusive nature is intentional, that someone or something is hiding the truth from us. The media plays a significant role in shaping these perceptions. Sensational headlines and dramatic storytelling often prioritize intrigue over accuracy, leaving audiences with more questions than answers. For example, when a new study about dark matter is published, it's not uncommon for news outlets to focus on the most speculative aspects of the research, rather than the nuanced details. This can lead to misunderstandings, such as the idea that dark matter has been discovered, when, in fact, scientists are still gathering evidence to confirm its existence. Social media has further complicated the landscape. Platforms like YouTube, Twitter, and TikTok are filled with videos and posts that blend scientific facts with wild theories, making it difficult for the average person to distinguish between credible information and baseless claims. This environment has given rise to a growing community of dark matter enthusiasts who are passionate about the topic, but often lack the scientific background to critically evaluate the information they encounter. As a result, misconceptions can spread quickly, further muddying the waters of public understanding. Despite these challenges, there's also a growing interest in dark matter among the general public. Many people are fascinated by the idea that there's so much about the universe we still don't understand. This curiosity has led to increased engagement with science communication, from documentaries and podcasts to online forums and citizen science projects. While not everyone may grasp the intricacies of dark matter, the fact that it sparks such widespread interest is a testament to humanity's enduring desire to explore the unknown. So, how can we bridge the gap between public perception and scientific reality? One key step is improving science literacy and making complex topics like dark matter more accessible. By presenting information in a way that's both accurate and engaging, we can help people develop a clearer understanding of what dark matter is and what it isn't. At the same time, it's important to acknowledge the role of curiosity and imagination in driving interest in science. After all, it's often the mystery and wonder of the unknown that inspire us to keep searching for answers. As we continue to unravel the secrets of dark matter, one thing is clear: the way we talk about it matters just as much as the science itself. By fostering a more informed and nuanced public conversation, we can ensure that the story of dark matter is one of discovery, not confusion. And who knows, perhaps the next breakthrough will come not just from a lab, but from a curious mind inspired by the mysteries of the cosmos. Now, let's explore an intriguing intersection: the relationship between dark matter and religion. For centuries, humanity has looked to the heavens for answers, seeking to understand the nature of existence and our place within it. Religious and spiritual beliefs have often provided frameworks for interpreting the cosmos, from ancient creation myths to modern theological reflections. But how does the mystery of dark matter fit into these narratives? Does it challenge traditional views of the universe, or does it offer a new dimension for spiritual exploration? For many religious traditions, the universe is seen as a creation of divine will, a vast and intricate design that reflects the power and wisdom of a higher being. Dark matter, with its invisible yet pervasive presence, could be interpreted as evidence of this divine craftsmanship, a hidden force that holds the cosmos together, much like the unseen hand of a creator. Some theologians have even drawn parallels between dark matter and spiritual concepts, suggesting that just as dark matter influences the physical universe, there may be unseen spiritual forces shaping our lives and destinies. On the other hand, the discovery of dark matter has also raised questions that challenge traditional religious views. For instance, if dark matter makes up the majority of the universe's mass, yet remains undetectable by conventional means. What does that say about the nature of reality? Could it imply that there are aspects of existence beyond human comprehension, even beyond the scope of divine revelation? These questions have sparked debates within religious communities, with some seeing dark matter as a reminder of the limits of human understanding, while others view it as an opportunity to expand theological perspectives. Interestingly, some spiritual traditions have long embraced the idea of unseen forces and hidden realities. In many Eastern philosophies, for example, the concept of an underlying energy or essence that permeates the universe is central to understanding existence. Dark matter, in this context, could be seen as a scientific validation of these ancient ideas, a tangible manifestation of the intangible. This convergence of science and spirituality offers a fascinating lens through which to explore the mysteries of the cosmos. At the same time, the scientific pursuit of dark matter has also led to discussions about the nature of faith itself. For some, the ongoing search for answers about dark matter mirrors the spiritual journey, a quest for understanding that requires both curiosity and humility. Just as scientists must grapple with uncertainty and incomplete knowledge, so too must individuals navigate the mysteries of faith and existence. This shared sense of wonder and exploration highlights the potential for dialogue between science and religion, rather than conflict. However, not all religious perspectives embrace the implications of dark matter. Some see it as a challenge to the idea of a purposeful, intelligently designed universe. If dark matter is simply a natural phenomenon, devoid of any spiritual significance, does that diminish the role of a creator? These questions reflect the broader tension between scientific discovery and religious belief, a tension that has existed for centuries but continues to evolve as our understanding of the universe deepens. Ultimately, the relationship between dark matter and religion is as complex and multifaceted as the phenomenon itself. For some, it reinforces the idea of a universe filled with mystery and wonder, inviting both scientific and spiritual exploration. For others, it raises profound questions about the nature of existence and the limits of human knowledge. What's clear is that dark matter has become a focal point for conversations that bridge the gap between science and spirituality, offering new ways to think about the cosmos and our place within it. As we continue to uncover the secrets of dark matter, it's worth considering how these discoveries might shape not only our scientific understanding, but also our spiritual and philosophical perspectives. Could dark matter be a bridge between the seen and the unseen, the known and the unknown? And what might it reveal about the deeper truths of the universe and ourselves? These are questions that invite us to look beyond the stars and into the very fabric of existence. As we turn our gaze toward the horizon of discovery, the future of dark matter research promises to be as thrilling as the mystery itself. Scientists around the world are gearing up for a new era of exploration, armed with cutting-edge technologies and bold theories that could finally bring us closer to unraveling the secrets of this elusive cosmic enigma. One of the most exciting developments on the horizon is the next generation of particle detectors, deep underground, in facilities shielded from cosmic interference. Experiments like LUX Zeppelin and Xenon are pushing the boundaries of sensitivity. These detectors are designed to capture the faintest signals of dark matter particles interacting with ordinary matter. If dark matter is indeed made up of weakly interacting massive particles, or WIMP, as many theories suggest, these experiments could be our best chance at detecting them directly. The stakes are high, and the potential payoff, a definitive answer to one of the universe's greatest mysteries, is worth every effort. But the search for dark matter isn't confined to Earth. Space-based observatories are also playing a crucial role in this cosmic detective story. Missions like the European Space Agency's Euclid Telescope and NASA's Nancy Grace Roman Space Telescope are set to map the universe in unprecedented detail. By studying the distribution of galaxies and the bending of light caused by gravitational lensing, these observatories aim to trace the invisible hand of dark matter shaping the cosmos. The data they collect could provide new insights into how dark matter influences the structure and evolution of the universe. Meanwhile, advancements in theoretical physics are opening up new avenues for exploration. Some scientists are investigating the possibility that dark matter might not be a single type of particle, but a complex family of particles with unique properties. Others are exploring alternative theories, such as actions hypothetical particles that could explain dark matter while also solving other puzzles in particle physics. These ideas are not just speculative. They're being tested in laboratories and through simulations, bringing us closer to understanding the true nature of dark matter. Artificial intelligence and machine learning are also revolutionizing the way we analyze data. With the sheer volume of information generated by experiments and observations, traditional methods of analysis are no longer sufficient. AI algorithms are now being used to sift through this data, identifying patterns and anomalies that might otherwise go unnoticed. This technological leap could accelerate the pace of discovery, helping us piece together the puzzle of dark matter faster than ever before. Of course, the road ahead is not without its challenges. Dark matter has proven to be a formidable adversary, evading detection despite decades of effort. But every failed experiment, every null result, brings us closer to the truth by narrowing down the possibilities. As the famous physicist Richard Feynman once said, "The first principle is that you must not fool yourself, and you are the easiest person to fool." In the pursuit of dark matter, scientists are constantly refining their methods, questioning their assumptions, and pushing the boundaries of what we know. So, what does the future hold? While we can't predict exactly when or how the mystery of dark matter will be solved, one thing is certain: the journey will be as enlightening as the destination. Each new discovery, each technological breakthrough, brings us one step closer to understanding the hidden forces that shape our universe. And as we continue to explore, we're not just uncovering the secrets of dark matter, we're also learning more about the fundamental nature of reality itself. As we look ahead, the question remains: will dark matter reveal itself in the next decade, or will it continue to elude us, challenging our ingenuity and resolve? Whatever the outcome, the search for dark matter is a testament to humanity's unquenchable curiosity and our relentless drive to uncover the truth. And in that pursuit, we may find not just answers, but new questions that inspire us to keep exploring, keep wondering, and keep reaching for the stars. Now, let's shift our focus to a provocative question that has sparked debate among both scientists and skeptics alike. Could dark matter be a hoax? While the idea might sound like something out of a science fiction novel, it's a question worth exploring, especially given how elusive dark matter has proven to be. Could it be that the entire concept is a misunderstanding, or even a scientific misstep? Let's dive into the arguments on both sides. Skeptics of dark matter often point to the fact that, despite decades of research, no one has directly detected it. They argue that the evidence for dark matter is entirely indirect, based on observations of gravitational effects that could potentially be explained by other means. For example, some propose that what we attribute to dark matter might instead be the result of modifications to our understanding of gravity itself. Theories like modified Newtonian dynamics, or MOND, suggest that the laws of gravity behave differently on cosmic scales than they do here on Earth. If true, this could explain phenomena like galaxy rotation curves without invoking the existence of invisible matter. Another argument skeptics raise is the sheer complexity of dark matter theories. Over the years, scientists have proposed a wide range of candidates for dark matter particles, from weakly interacting massive particles, or WIMP, to actions and sterile neutrinos. The fact that none of these have been definitively detected has led some to question whether dark matter is simply a placeholder for our lack of understanding. Could it be that we're trying to fit the universe into a framework that doesn't quite match reality? Despite these arguments, the scientific community largely dismisses the idea that dark matter is a hoax. One reason is the overwhelming consistency of the evidence. From the way galaxies rotate to the way light bends around massive objects, the effects attributed to dark matter are observed across the universe. These phenomena are difficult to explain without invoking some form of unseen matter. Additionally, the cosmic microwave background, the afterglow of the Big Bang, provides a snapshot of the early universe that aligns perfectly with the presence of dark matter. The patterns in this ancient light are a key piece of evidence that supports the existence of dark matter as a fundamental component of the cosmos. Moreover, the idea that dark matter is a hoax overlooks the collaborative nature of modern science. Thousands of researchers from around the world, working independently and using different methods, have all arrived at the same conclusion: dark matter is real. While it's true that science thrives on skepticism and questioning established ideas, the consensus around dark matter is built on a mountain of data and rigorous testing. To dismiss it as a hoax would require an alternative explanation that can account for all the observed phenomena, something no theory has yet achieved. That said, the possibility of being wrong is always present in science. It's part of what makes the pursuit of knowledge so exciting. If dark matter were somehow disproven, it would be one of the most groundbreaking discoveries in the history of physics. But until then, the evidence points overwhelmingly to its existence. The mystery isn't whether dark matter is real, it's what it actually is. And that's a question that continues to drive scientists forward, pushing the boundaries of what we know about the universe. So, while the idea of dark matter being a hoax is an intriguing thought experiment, the weight of evidence suggests otherwise. The real challenge lies in uncovering its true nature, a challenge that keeps us looking to the stars, searching for answers in the vast, invisible expanse of the cosmos. Now, let's take a moment to imagine a world where the mystery of dark matter is finally solved. What would it mean for humanity to uncover the true nature of this elusive substance? The implications stretch far beyond the realm of science, touching on philosophy, technology, and even the way we see ourselves in the universe. From a scientific perspective, understanding dark matter would revolutionize our knowledge of the cosmos. It would provide answers to some of the most fundamental questions in physics, such as how galaxies form and why the universe behaves the way it does. This breakthrough could lead to new technologies, much like how our understanding of electromagnetism paved the way for everything from radios to smartphones. Imagine the possibilities: advanced space travel, new energy sources, or even entirely new fields of science we can't yet conceive, but the impact wouldn't stop at science. Solving the dark matter mystery would also have profound philosophical implications. For centuries, humans have looked to the stars and wondered about our place in the universe. Discovering what makes up 85% of its mass would force us to rethink our understanding of reality itself. Are we alone in the cosmos, or could dark matter be connected to other dimensions or even intelligent life? These questions could reshape our worldview, challenging long-held beliefs and inspiring new ways of thinking about existence. On a societal level, the discovery could unite humanity in a shared sense of wonder and curiosity. Just as the moon landing brought people together in the 1960s, solving the dark matter mystery could spark a new era of global collaboration and exploration. It might also inspire future generations to pursue careers in science, technology, engineering, and mathematics, driving innovation and progress for decades to come. Of course, with such a monumental discovery comes responsibility. Understanding dark matter could give us unprecedented power over the natural world, raising ethical questions about how we use this knowledge. Would we use it to explore the stars, or could it be weaponized? These are challenges we'd need to address as a society, ensuring that the benefits of this discovery are shared equitably and used for the greater good. Ultimately, solving the mystery of dark matter wouldn't just answer a scientific question. It would redefine our relationship with the universe. It would remind us of how much we still have to learn and how interconnected we are with the cosmos. And perhaps most importantly, it would show us that even the greatest mysteries are not beyond our reach. The journey to understand dark matter is more than a quest for knowledge. It's a testament to humanity's endless curiosity and our drive to explore the unknown. Now, as we wrap up this journey through the mysteries of dark matter, it's time to turn the spotlight over to you. What do you think about the dark matter conspiracy? Could there be forces at play, governments, secret organizations, or even extraterrestrial beings deliberately hiding the truth about this elusive substance? Or do you believe the answer lies in the natural workings of the universe, waiting to be uncovered by science? Share your thoughts in the comments below. Who do you think might be behind the mystery of dark matter, and what could their motives be? Your ideas could spark a fascinating conversation, and who knows, maybe your perspective will shed new light on this cosmic puzzle. If you enjoyed this deep dive into the secrets of the universe, don't forget to hit the like button and subscribe for more mind-bending explorations. And make sure to ring that notification bell so you never miss out on the latest mysteries we uncover together. The universe is full of secrets, and we're just getting started. Thanks for watching, and I'll see you in the next video. As we bring this exploration to a close, let's take a moment to reflect on the incredible journey we've taken through the enigma of dark matter. We've uncovered how this invisible substance makes up 85% of the universe's mass, yet remains frustratingly elusive. From the groundbreaking discoveries of Fritz Zwicky and Vera Rubin to the cutting-edge experiments of today, the search for dark matter has reshaped our understanding of the cosmos. But the mystery deepens when we consider the conspiracy theories. Could someone or something be hiding the truth about dark matter? Whether it's governments, secret organizations, or even advanced extraterrestrial civilizations, the possibility of a hidden hand adds a layer of intrigue to this cosmic puzzle. We've also explored alternative explanations, like modified Newtonian dynamics, and pondered how dark matter might connect to the multiverse or even parallel dimensions. Yet, despite all the theories and experiments, dark matter remains one of the greatest unsolved mysteries of our time. So, as we leave this topic behind for now, let's end with this thought. What if the truth about dark matter is even stranger than we've imagined? What if the answers lie not just in the stars, but in the very fabric of reality itself? The universe is vast, mysterious, and full of secrets, and dark matter might just be the key to unlocking them. Thanks for joining me on this journey, and remember, the search for answers is far from over. Until next time, keep looking up and wondering what else is out there.